Humphreys Whitehead cosmology also uses Einstein's general relativity as a basis. What is the difference? The difference is that the assumption applied to the boundary conditions when solving Einstein's equation. So 100 years ago, 1922, Alexander Friedman used the assumption of homogeneous and isotropic universe based on the cosmological principle, right? And then he solved that, and then that was basically basis of the modern cosmology. The creationist cosmologist Humphrey actually used different assumptions. What? We may be at the center of the universe. Others are the same. Others are solving the equations and explanations and Einstein's relativity. Everything is the same. Only difference is the assumption. Because that assumption is just assumption. You cannot prove it. Okay, that is the whole point. You guys understand and say yes on the chat, because this point is the most important thing in the entire lecture regarding this cosmology. Type yes if you understand. If you don't, ask a question now. Okay, so I see a few yes. A few yes here. So I'm gonna type. So I'm gonna move on here. All right. So Dr. Humphrey actually assumes that our galaxy is near the center of things. Now, our Friedman universe, our standard cosmology, is a homogeneous and isotropic universe according to the cosmological principle. So this can be modeled by using an expanding balloon, right? Humphrey's model shouldn't use this kind of thing. Humphrey's model end up having different, because we are at the center. That means the universe is not isotropic, anisotropic, and we may be at the center. Then the effect is different. The Humphrey's model states that there are center and the boundary, which I will explain in detail in the next lecture, not today. Today is just introducing a little bit. So let's imagine you have a balloon that is basically our Friedman model, right? But Humphrey's model is you use your finger and you poke, you push the balloon with your finger. What happens? It will dent like this, right? So that is actually Humphrey's model. That is only difference. Rest of the physics, the same. But when you do this, things are different. The general relativity predicts that the gravity field would slow down. The stronger the gravitational field, the greater the effect of time. Okay, that really happens. And actually the atomic clock in Boulder, Colorado here, actually here, this one, oops, sorry, runs 5 microseconds a year faster than Greenwich, England. And the atomic clock in the GPS satellite runs faster by 38 microseconds a day. This is something that happens in reality. Humphrey's model applies the concept of this curved space-time and the change of velocity of basically light speed. I'm not sorry, not the speed of time, okay, into the entire universe. That's the Humphrey's model. And when you push the balloon with your finger, it will dent, and what happens to the space-time when it's distorted? What happens is the clock speed is affected by the gravitational energy. You see this top right. So this is Humphrey's model. And graph is gravitational energy, okay? Basically the space-time bends, then it affects the gravitational energy. When you go down to the gravitational energy, the clock ticks slowly. And basically you apply this into the entire universe in this center and boundary model, you can explain the Bible. So what happens is here, again, the clock speed is affected by gravitational energy, and gravitational effects can be simulated on this trampoline. So we're gonna use this trampoline next time to explain what happens here. These gravitational energy modeling and the trampoline, they're mathematically analogous. So basically you use the same equation that is used in this trampoline, basically expressing the geometry of this trampoline, or you can correlate this to this gravitational energy equation and you can solve it. So that's what this Humphrey cosmology did. Here again, the relative speed of clocks is a function of gravitational energy and the distance from the center of the cosmos. So time slows down at lower potential energy until a critical value is reached. Here, you see this red 0.5 c squared, and you don't need to know, this comes from the equation. So space-time bends and it goes under this critical point, time stops. Okay, according to these equations from the solution from the Einstein's equation that is now simplified using this boundary condition, which is basically using the similar approach as Friedman, but assumption was different. Again, and then the assumption is just assumption. There's no scientific way of proving it right or wrong, right? So we can choose. Friedman chose there's no center. We choose there may be center. That's the only difference. So using the assumption of galactocentricity and water origin hypothesis, which I will explain in the next lecture, Humphreys constructed his cosmology based on the theory of general relativity that explains the light travel time issue consistent with the time frame of the biblical creation. Okay, so I'll go over the Humphreys cosmology in more detail in the next lecture. Okay, so we're finished today.
I have a question about this current slide. So what is the force that Humphrey is using to explain the indent that we see in our galaxy?
It's a gravitational energy. So when you have you have the mass that will bend the space-time. That is from Einstein's theory. Now, when you have these galaxies kind of circling around, not exactly circling around, but just assume for the simplicity, circling around our galaxies. Basically, these mass are sort of concentrated at one point that bend the entire space-time of the entire universe.
Thank you for your lecture. I was just wondering, can you just briefly summarize the difference between the cosmological principle and theory of relativity? Are they, you said these are two foundations.
Those are different things. General theory of relativity is how you see the gravity. And Einstein saw the gravity as the curvature of space-time. So that is a different thing. Cosmological principle is not even theory. It is just a principle. It is just an assumption. So what I wanted to emphasize was that our whole Big Bang or whole modern cosmology is based on these two pillars. One pillar is Einstein, and that seems to be all right. But second pillar is based on philosophy. You choose the philosophy of mediocrity. Okay, does that answer your question?
Thank you.
But I got a question about the distribution of matter in the universe. So cosmological principle claims that it's homogeneous, but when the data that you have presented shown that it is, because if you observe that galaxies are moving faster away from us, the further they are, then wouldn't that be a clear, I guess, evidence against that it is distributed homogeneously?
Yes, however, again, as Steve Hawking said, there is another way of explaining it. There is an alternate explanation that if you assume, again, this is assumption, if you assume that the universe might look the same in every direction as seen from any other galaxies too, then we don't need to worry about this centricity because the space-time itself expands. Then we can explain everything.
If we are the center of the universe, what is the implication of that?
The implication is that this one here in this slide, the universe might look at the same in every direction. If you are really at the center of the universe, the cosmological principle is wrong, which means universe is not homogeneous. Even this, look at this. We are at the center here. This is our galaxy at the center, Earth. And then these look sort of a spider web thing, but sort of with this circularly surrounding us, looking like this. And if you just interpret this as a real movement, right? Then, or if it's a real structure, then that means we are somewhere near the center of the universe. And then basically it breaks the cosmological principle. If it breaks the cosmological principle, it breaks the Friedman's equation. If it breaks the Friedman's equations, modern cosmology doesn't work. You have to reinterpret everything. You have to go back to Einstein and start from there with a new assumption. And basically, if you take this new assumption that there's a center, there is boundary, then there is very close to Humphrey did. So if you go to NASA homepage, it is written like this: how large is the universe? Nobody knows. Actually, that is more honest answer. But this is just an estimation based on the assumption that the universe is 13.8 billion years old, and then space-time is keep expanding. Then basically this is a resultant understanding of the size. But nevertheless, it is a fact that the universe is really huge. The number may be off, but it's really huge. If it is really huge and then the light speed is the same, then universe is really old. Okay, so
yeah.
Yeah.
So how do you reconcile that with the 10,000 year timeline of the creation of universe?
That is again by using the relativity of time. Relativity of time. This one. Time. So clocks ticks different speed in different gravitational potential. That is a fact. Because even the GPS clocks in the GPS satellites, you have to compensate that, putting this Einstein's equation, because otherwise clocks ticks differently from Earth and basically you apply that into the whole space. That is Humphrey's.
So it's for time to be, say 10,000 years. That means that at the center of the universe, there has to be something. The mass has to be massive then, right? Because then it would need to bend it enough.
No, mass can be uniform, but still it will bend. So just imagine you have a balloon and there is a metal plate, right? And you have the uniform mass distribution. You put it, it'll still bend. Because it has direction, because it has center, because it has boundaries. And again, this is just one of these theories, and there are several others, but I use Humphrey's because I believe Humphrey's one is most complete amongst those. And that the reason being is, again, the Big Bang or these modern cosmology has been 100 years, and you put zillions of dollars, put it into scientists, satellites, spacecrafts to explain what is observed. And then they changed 60 times. The Big Bang theory has been changed 60 times to fit into the observation. Creation cosmology, what is history? Maybe 30 years at most. And how many scientists who have this biblical creation belief with the entire knowledge of Einstein's theory, who could make their own cosmology using Einstein? How many people you will have on the Earth? Only a few. Okay. And you have to just sacrifice everything because you cannot work in the secular institution by doing this. So you have to retire early and then basically devote your life into doing this. Basically, you just sit down on the desk and then you have to just solve these equations for 30 years. That's what you do. How many people can do that? Okay, without support, without any money. So, so if these creationist cosmologies are supported as much as this regular scientists and then access to all these satellites, everything, I think there can be much better theories that explains this biblical creation than the Big Bang theory, I'm sure.
I have just a thought.
Sure.
So when God created everything, he also created time, right? Because he doesn't function by time. So is the assumption that time, like, there's a question of what is time and how you measure time as well. And what did time run differently during day one versus later on in creation?
So two things. One is day one, and now I believe the clock ticking was the same on Earth. Only different was a relative time over there. And your also question implicates what happens before starting, right? This universe. There's no time because God created space-time itself in day one. So before, there's no such a thing. Time, there was no space before creation. Okay, so I think that is more philosophical thing and theological thing that may be above my pay grade, but so that's my understanding. So we don't need to worry about because that is not what we're supposed to worry about because God didn't really explain it because we don't need to know. But it's clear from the scripture that the earth is not billions of years old because that contradicts the gospel itself. So Big Bang theory has the same implication as evolution.